Now, let's get this started with people. Firstly, let's talk about waves. It's a wave, it's a wave, it's a bird, it's a plane. No, it's Wave Man. Whatever, we're not gonna make a superhero called Wave Man. Now, waves are literally everywhere, whether you like it or not. Waves can rise and fall in the oceans. It's what makes earthquakes go ahead and make those solid big waves, create tremors, and the waves that you can literally make waves in this book itself. Like, that's technically a wave. Also, not that obvious, too. Light waves are literally going from our eyes to you. Also, it can technically also be called a particle. And there are many other ways that you can and cannot see in this entire world. Visible light is practically the only waves you can see. Microwaves are what we can use the microwave to cook our food. And gamma rays is what turns Bruce Banner into Hulk. Also, Hulk hates Bruce Banner. And Bruce Banner, I'm not sure if he hates Hulk. Yeah. It's also what makes Wi-Fi and lets you watch this video online on YouTube, unless you've downloaded this video and you've disconnected from Wi-Fi. But it's also the reason what makes those little waves inside that little phone or whatever device you're using to watch this video works that well. It's also what makes night vision goggles work, and that's why waves are important. Now, what are waves? Waves are just a form of energy, and you basically know what it looks like. It looks like this. Sorta. You can use a slinky to indicate. So you can basically like boing and slinky, and that part right there, like it'll travel here, and then it'll travel back there, and then like, it's like compressions. Like if you try to describe a wave, you basically have to figure out the huge amount about waves and how they behave and everything by examining their shape, timing their motion, and yeah. Basically like a ripple in the river. Now imagine a person just splashed a random rock into a river and then it becomes a ripple. Now each ripple is at the top of the wave, and the distance between the ripples, about my fingertip here, is called the wavelength. And the number of ripples that hit this leg every second is called the frequency. Basically the speed. And then the height of the ripple, also about half of my finger, is called the amplitude. And now, the shorter the wavelength, the higher the frequency. And the longer the wavelength, the longer the frequency. The lower the frequency. Which is why red is a very, very low frequency because it has a long wavelength. And violet has a very, very high frequency as it has a shorter wavelength. Nice. It's also not just water waves that actually do this. It's also about light waves and sound waves, too. It's what makes you be able to hear me unless I do this, like mute my mic. And I'm like, la la lo li la lu la la. You didn't hear me, did you? Or you did, but just not that well. Okay, that's better. And sound waves, it's basically like the ding you make so that it makes the sound like la 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 la. It's like what makes echoes. Now, echoes are annoying when you're trying to record. Like echo, 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 echo. Like that happens. It's really annoying. And sound waves literally reflect off surfaces, just like waves of water. You can tell that sound actually reflects off surfaces when you hear those echoes. And it's really annoying when you're trying to be a producer and recording, which is why you need low echo rooms so that you have some ideal places to actually record some music. And also it's louder the sound, the higher the frequency and the shorter the wavelength. So it's also electrons and electricity charges that seems to happen too. Now magnets themselves, if you attach them together, they actually make this thing called the magnetic field, which is basically these waves. And you can literally use electricity to make an electromagnet that gets, like, as long as it's near enough, like iron comes there. And if you like coil it enough, I've tried this myself, it's a pretty fun experiment, it'll be stronger. It's also what makes doorbells work, but that's another topic. And this guy right here, a guy named James Clerk Maxwell, he's the one who found out about electromagnetic waves, and he's the one who named them all like radio waves, visible waves, gamma rays, so on. And here's the whole electromagnetic spectrum, if you will. Now, there's this little thing in between microwaves and infrared waves called the terahertz. And it's basically a version of the X-ray that won't damage our cells of long exposure. So you can expose yourself to terahertz as much as you want, and it won't kill you. And it can also be emitted from a little microchip, which is great, because now you can use it for airport security. Problem is, We have no idea how to make it. Also, it was previously overlooked, so there's not much research going on in that yet. And you can use these waves to actually peer into space-time, because when you look at the moon, you're actually seeing what happened to the moon 1.3 seconds ago. Because it takes 1.3 seconds for light on the moon to get to us. So we're actually looking at the past of what happened in the past when you look up. Those stars up there are actually what happened billions of years ago. Or just a few years ago sometimes. And that's all I have for today. So I hope you guys enjoyed this episode. See you guys soon. Now, next episode we're talking about the speed of light and the shape of the universe. See you guys soon. Now, peace.